I would like to introduce you to a radically different vacuum cleaner, which for the first time does not emit airborne dust into the room's air as all existing vacuums do. Our closed-loop vacuum also truly never loses suction and does not require replacing an air filter. It is also energy efficient and convenient in operation. All existing vacuums utilize the same traditional concept. They suck in the room's air, and the created airflow picks up the dirt and dust from the surface being cleaned. Then, the polluted air goes to an air filter, which is supposed to catch the sucked in dirt and dust and return the cleaned air back into the room. Practically all existing vacuums employ as an air filter some kind of porous filter. They can be paper or cloth bags. They can be made from washable plastics with flat or pleated shape, etc. But all of them work in the same way. They retain only the dust which are coarser than the size of their pores, and inevitably, together with the air, release the finer dust. Even such fine dust is usually visible only in sunbeams. It can be suspended in the room's air for a long time and often contains pollen, mites, pet dander that is especially harmful for people suffering from asthma, allergies, and other respiratory diseases. Another problem of existing vacuums is that they lose suction as soon as their porous filters become clogged with dust, because such clogging creates a barrier to the airflow. For suction restoration, you have to replace the clogged filter or clean it itself, which is usually not a pleasant job. In the early 90s, British inventor James Dyson proposed to equip the household vacuum cleaner by a centrifugal air filter. In other words, a cyclone. Dyson claims that his vacuum never loses suction because a cyclone can never be clogged. That is true. However, a cyclone possesses much lower retaining ability than a porous filter, and because his vacuums, the same as all traditional vacuums, exhaust the used air into the room, Dyson was forced to install, after a cyclone, an additional air filter. This additional air filter is also a porous filter, and even though it is carefully concealed and never mentioned in commercials, you will easily find it as soon as your new Dyson loses suction, the same as all existing conventional vacuums. Also obvious is that Dyson's vacuums, just as all traditional vacuums, emit into the room the airborne dust finer than the size of the pores of their hidden post-cyclone porous filter. Since the early 90s, many companies began to equip their vacuums with so-called HEPA filters. They're also porous filters, but with smaller sized pores. Even though they possess higher retaining ability, they also cannot retain dust finer than the size of their pores. Moreover, HEPA filters create much higher resistance to the airflow that limits suction. For keeping the suction, designers are also enforced to equip vacuums with more and more powerful motors. If in early 90s, the typical upright household vacuums were equipped by only a 4 to 5 amps motor, today most of them are monsters with 12 amp motors, even though they provide the same suction. Let me summarize the flaws of all existing conventional household vacuum cleaners. They're unable to retain all sucked-in particulate pollutants and emit finest airborne dust containing allergens into the room. They quickly lose suction, and they're energy inefficient, heavy, and clumsy in operation. To eliminate the flaws of traditional vacuums, we propose to completely change the concept of the vacuum cleaner. Instead of sucking in the room's air and releasing it back after filtration, we propose to reuse the same portion of air to pick up dirt and dust and transport it to the air filter. In this case, the vacuum does not exhaust the used air at all, which prevents the saturation of the room's air by any kind of escaped airborne dust. Completely eliminating exhaust of the used air also allowed to employ a centrifugal air filter alone, without an additional porous filter. The finest airborne particles, which are not retained by the centrifugal air filter, continue to circulate in the closed-loop system, agglomerating in this way into bigger clusters, and as soon as they become big enough, they are caught and collected by the centrifugal air filter. The absence of a porous filter provides the vacuum truly stable suction because a centrifugal filter practically cannot be clogged. It also allows equipping the vacuum with a small motor because a centrifugal air filter exerts much smaller resistance to the airflow than a porous filter. A small motor also makes the vacuum less energy consuming, lighter, and more convenient in operation. We have spent a few years developing the practical implementation of our idea, and finally were granted a US patent. We have built and tested many experimental models of the closed-loop vacuum. For example, this one shown in the picture. It is equipped by only a 2.4 amp motor. Testing of this model showed that the dust concentration in the room's air after vacuuming is a dozen times smaller than using a traditional vacuum equipped by a 12 amp motor and brand new paper air filter bag. Now let me enumerate all the advantages of the closed-loop vacuum compared to traditional ones. First, it does not emit fine dust and airborne agitators into the room's air. It provides truly stable suction, independent of the fullness of the air filter container. It is simple in maintenance, no need to replace or wash clogged air filters. It is energy efficient, and it is light and convenient in operation. Now we're looking for partners who can help us to bring our innovative and patented closed-loop vacuum cleaner to the market. If you have any questions or are interested in getting involved, please contact us.